Hello friends, myself Aher from RBNB College Sirampur. Today I deliver a lecture on thermodynamics from XII.Sci Maharashtra State Board. In thermodynamics, we know the thermodynamics. Thermodynamics means a branch of physics which deals with the study of concept of heat and concept of the temperature. Now concept of temperature can be understood by Zeroth Law of Thermodynamics. Now why it is called as Zeroth Law? Because this law is proposed after first law of thermodynamics and second law of thermodynamics. That's why it is called as Zeroth Law of Thermodynamics. For studying the Zeroth Law of Thermodynamics, we know thermal equilibrium. Thermal equilibrium. When we consider two bodies, hot body is in contact with cold body. Then this hot body loses its energy and cold body gains that energy. There is transfer of heat between hot body and cold body. After some time, both these bodies attain same temperature. That is called as thermal equilibrium. So we can say that when two bodies are said to be in thermal equilibrium, then temperature of both these bodies remains constant. Temperature of two bodies remains constant, then these two bodies are said to be in thermal equilibrium. Now in case of Zeroth Law, we consider three systems. System A. For Zeroth Law, we consider schematic diagram. If you consider this one is the body A or system A. If you consider another system, say B, and third system, say C. When system A is in thermal equilibrium with system C, this arrow, double arrow indicates that there is transfer of energy between system A and system C. Now, if system A is in a thermal equilibrium with system B, now in that case, system A is in thermal equilibrium with system C. Means there is transfer of energy between system A and system B. Then according to Zeroth Law, we can say that this system B and system C are in thermal equilibrium with each other. And therefore, according to this, we can say that these three systems, system A and system B and system C, all these bodies are in thermal equilibrium and they attain the same temperature. This is the zeroth law of thermodynamics. So, we can write the statement of zeroth law of thermodynamics. According to this law, we said that when two bodies are in a thermal equilibrium with third body, means body A and body C are in thermal equilibrium with body C, then all bodies are in thermal equilibrium. So, this is the statement of zeroth law of thermodynamics. So, according to this law, if you consider three systems, system A, system B and system C, if both these systems are in thermal equilibrium, means system A and system C, and if system A and B is also in thermal equilibrium, then remaining system B and C are also in thermal equilibrium. And that's why statement of zeroth law of thermodynamics is as like that: when two bodies are in thermal equilibrium with third body, then all bodies are in thermal equilibrium, means they attain the same temperature, and this is the zeroth law of thermodynamics. Now, with the help of zeroth law of thermodynamics, we can record the temperature of body. Because when thermometer is in contact with the body, then due to the thermal equilibrium between body and thermometer, mercury rises inside the thermometer and which shows the constant reading. That reading shows that the body and thermometer both are in a thermal equilibrium. So, in this way, we study about the zeroth law of thermodynamics. Now, we have to study the internal energy. We have to study the internal energy. For studying the internal energy, if we consider a hot water poured in the vessel, hot water is poured in the vessel, and this vessel is placed on the table. Now, in that case, this hot water is called as system. It is called as system, or it is also called as thermodynamic system. And the vessel shows the boundary between system and surrounding. And other than all these things that are called as surrounding, or this surrounding is also called as environment. So we can say that when hot water is poured inside the vessel, then hot water acts as a system, thermodynamic system. Then vessel acts as a boundary between surrounding and system, and remaining part other than the system is called as surrounding or environment. So according to this diagram, we draw the another diagram. In this diagram we will show the system. This is the system. Then this one is the boundary. And remaining part is called as surrounding. So in this way we remember this system, surrounding and boundary. Now this system plus surrounding both forms universe. In case of thermodynamic system or thermodynamics, universe means combination of system and surrounding, or in another word we can say that system and surrounding form the universe. Now in this diagram, system, this system consists of large number of particles. This system consists of large number of particles, and energy associated with these particles is called as internal energy of the system. So we have to write the definition of internal energy. We have to write the definition of internal energy of a system. Very simple definition. Internal energy of a system. As from this diagram, we can say that this system consists of large number of particles or molecules. The energy associated with that molecules is called as internal energy. But remember that all these particles are in random motion and disorder motion, and energy associated with all these molecules is called as internal energy of a system. So from this diagram we can write the definition of internal energy. It is simply energy associated with random, disordered motion of molecules of system is called as internal energy of a system. So simply remember that. What is internal energy of system? It is the energy associated with random disorder motion of molecules of the system, that is called as internal energy. Now if we consider a water, hot water, or we consider only water, is poured in the vessel. It consists of n number of molecules, and if you observe from naked eye, then this observation is macroscopic. So under the macroscopic observation, we see that water is at the rest, which is poured in the water, which is poured in the vessel. As water is at the rest, therefore its velocity is 0. As velocity is 0, therefore its kinetic energy is 0 and also potential energy may be 0. So this is our macroscopic observation. But under the microscopic observation, under the microscope, so for microscopic observation, if you consider this some portion of the water, then it consists of large number of molecules inside the water, as like this one, and all these molecules are in random motion in all directions, and this motion is also disordered motion. So energy associated with all these molecules is called as internal energy, and we observe under the microscopic, and then we find that all molecules are in random motion and in disordered motion, and this energy associated with all these molecules is called as internal energy of a system. That is called as internal energy of a system. Now if we consider monoatomic gas molecule as a argon, in that case there is only linear motion. So kinetic energy is due to the linear motion. So there is translational kinetic energy. If you consider polyatomic gas molecule as like the carbon dioxide, so in that case there are rotational kinetic energy, there are also vibrational kinetic energy, and there are also translational kinetic energy in case of polyatomic gas. Now if we consider solids and liquids, so in case of solids and liquids, there is intermolecular force of attraction. There is intermolecular force of attraction, and this is our microscopic observation. Remember again, that observation is also microscopic observation. And due to the intermolecular force of attraction, there is potential energy in case of liquids and solids. Now this internal energy of a system can be denoted as capital U. It is denoted as like capital U. So this is all about the internal energy of a system. So remember again, what is internal energy? It is simply energy associated with molecules of the system, and all these molecules are in random and disordered motion. This is about the internal energy of a system. Now concentrate on this diagram again. We have to study about the definition of system. So for system, it is called, in case of thermodynamics, it is called as thermodynamic system. And we define the definition of thermodynamic system from this diagram. What is thermodynamic system? Now concentrate on the diagram of the system. So from this diagram we can say that it is collection or group of an object which form a unit and having ability to transfer energy to the surrounding, and that's why it is called as thermodynamic system. So simply we can say that what is thermodynamic system? It is group of an object which form unit and that unit having ability to exchange energy to surrounding. That is called as thermodynamic system. So in simple word, we can write thermodynamic system from this diagram. We know that there are large number of molecules inside the system, and therefore we can say that thermodynamic system is collection or group of an object which form a unit, that unit having ability to exchange energy from system to surrounding or exchange energy to the surrounding, that is called as system. So this is about the system. Then what is about surrounding? Remaining part or anything except the system is called as surrounding, or remaining part is called as surrounding. Or in another word, we can say that anything which is not part of the system is called as surrounding. Or in simple word, we write the definition of surrounding or environment. What is surrounding or environment? Anything which is not a part of the system, that is called as surrounding. So except this part, remaining part of universe is called as surrounding. So simple word, we can write the definition of surrounding or environment. Anything which is not a part of the system is called as surrounding or environment. Now we have to study the classification of system. We have to study the classification of system, which is very simple. This thermodynamic system can be classified in three ways. One type of thermodynamic system is, say, open system. Second type of thermodynamic system is closed system. And third part of system is isolated system. So this thermodynamic system is classified into three ways: open system, closed system, and isolated system. We consider closed system. If we consider one example, we take a vessel, and in that vessel there is water. This vessel is on the gas burner. After some time, due to the heat, this water become hot water, or this water become boiling water. This water will become boiling water. Then when it become boiling water, then this heat is exchanged between surrounding, and means we can say that heat means energy. So in that case, energy is exchanged between system and surrounding. At the same time, steam is also exchanged between system and surrounding. This steam is called as matter. This steam is called as matter. So in that case, both heat energy and matter both are exchanged with surrounding easily. That such type of system is called as open system. Such type of system is called as open system. So according to this one, we can define the definition of open system. Open system is a system in which heat energy and matter both are exchanged to the surrounding is called as open system. So we write, what is open system? In that case, heat and matter both are exchanged with the surrounding is called as open system. Very simple. In case of open system, heat energy and matter can be exchanged from system to surrounding and surrounding to system. That is called as open system. In that case, as water is boiling water, system is at higher temperature. That's why heat and matter both are exchanged from system to surrounding, and such system is called as open system. Closed system. Now in case of closed system, if you consider closed kettle as like this one, and in this kettle hot water is poured, now in that case steam does not allow to exchange with the surrounding, only heat is exchanged, only heat energy is exchanged to the surrounding. Such system is called as closed system. So according to this one, what is closed system? Only heat energy is exchanged such system is called as closed system. So with the help of this diagram, we can write the definition of closed system. Closed system is a system in which matter does not exchange with the surrounding, or in another word we can say that only heat energy is exchanged to the surrounding. Such system is called as closed system. So remember again, what is closed system? The system in which only heat energy is exchanged and no matter is allowed to the exchange. Such system is called as closed system. Now remaining system, isolated system. In that case, we consider thermos flask. So this is isolated system, and in this thermos flask, if we pour hot water, this hot water remains as hot because no heat energy and no matter exchange with the surrounding. So this system is called as isolated system. In that case, no heat and no matter is exchanged with the surrounding. Such system is called as isolated system. An example of isolated system is thermos flask. In case of thermos flask, no energy leaves this system and no energy enters in the system, and that's why such system is called as isolated system. So according to this example, we can say that what is isolated system? The isolated system is those systems in which no heat energy and no matter are exchanged with the surrounding. Such system is called as isolated system. So this is the classification of thermodynamic system. In case of thermodynamic system, there are three systems: open system, closed system and isolated system. Today we stop here.